Okay, so, straightforward problem, just really applying the idea of the uniform acceleration. No tricks, no curveballs, straightforward. But I know some of you don't like to do the velocity conversion because you're afraid of it. I've seen it before. Some students are. So what we're going to do now is we're going to do the other way around. So let's go now, instead of the velocity conversion, we're going to do the distance and time conversion. Okay, and here, everything is the same, but instead of starting by converting our velocity, which was a 54, we're going to keep that velocity at 54. So our velocity, initial velocity, is 54 kilometers per hour. I'm going to keep it. But our distance, our delta x, which is 240 meters, we're going to convert that into kilometers, right? And we know that 1 kilometer is the same thing as 1,000 meters, and therefore meters and meters go away. And this is the same thing as if I had 0.24 meters. I'm sorry, kilometers. Okay, likewise, our time is 24 seconds. That's how long the red light is red for. And we know that there are 3,600 seconds on every hour. So this means that my seconds and seconds go away, and I'm left with the beautiful number of, this is going to be, let me do this, 24 divided by 36 times 10 to the 2. Because that allows me to do, real quick here, divided by 2 is 12, will be 18, divided by 2 again, that will be 6 over 9, that will be 2 over 3, so that's 2 over 3. Let me go ahead and put it here. So that's 2 over 3, 2/3 times 10 to the 2, so I can go ahead and put it over here, and 10 to the minus 2, right? Same thing. And this is in hours. This is how many hours the light is red for. And, you can already think, some people already don't like this method already because you have to do 2 conversions instead of 1. And obviously you can start getting these numbers that are not as simple as before. Let's put it like that. But, nonetheless, it's exactly the same idea. So now that we have these converted, we can go ahead and do our uniform acceleration. And again, reminder, this is delta x v naught times t plus acceleration time squared divided by 2. We have everything we need. Now our distance position is going to be the 0.24. So 0.24, not 24, times my velocity, 54 kilometers per hour, times 2/3 times 10 to the minus 2 hours, plus the acceleration times, divided by 2, times, again, the 2/3 times 10 to the minus 2, and this is squared. Okay, so this guy here becomes 0.36. So, okay, so this is going to be 0.24 minus 0.36. I'm going to go ahead and send this to multiply to the other side already. So times 2 equals acceleration times 2/3 times 10 to minus 2 squared. And here is, word of warning. I've seen students do this. You can't really do that because you have that square there. So if you were to do that, you need to have a 2 that's left over here, and you still have to have 1/3 times 10 to the minus 2 squared. So watch out. Best to leave it. Okay. So this means that I can now send this guy dividing over here, so I can go ahead and do this neat trick that technology allows me to do. And you're going to note that it's going to be a negative number, right? And therefore our acceleration is going to turn out as a negative number. And it turns out to be negative 5,400 kilometers per hour squared. The unit-wise, same exact idea as here, but now we're talking about kilometers and hours instead of meters and seconds. Okay, so again, this is also the answer for part 1. both would be correct. Unless specified the unit, both would be correct. Okay, so what's the acceleration that the lady needs to apply? It's the deceleration, right? It's 5,400 kilometers per hour squared. All right, and then what is the velocity, right? The velocity, and we know the velocity will be velocity initial plus acceleration time, as noted before. So therefore, the velocity at time 24 seconds, or 24 seconds, which is 2/3 times 10 to the minus 2, will be the 54 kilometers per hour initial plus the negative 5,400 times the 2/3 times 10 to the minus 2. Note that interestingly, this 10 to the minus 2 cancels these two guys here. So here we have 54 minus 2/3 of 54. Okay, so our answer is going to be 1/3 of 54, right? So the velocity will be 54 divided by 3, which is 18 kilometers per hour. And I'm not sure if we checked the units before, but we can now if we want. Let's check it over here. What we're doing here is we have kilometers per hour on the velocity, and then we're multiplying by, or summing up of kilometers per hour squared times hours. So hours squared, kilometers per hour is the unit we're going to end up with. So this is the answer right here. Okay, 18 kilometers per hour is also a correct answer. If you convert 18 kilometers per hour into meters per second, you get 5. So I'll get there, no problem whatsoever. If you convert the 0.146667 into from meters per second squared into kilometers per hour squared, it's the 5,400. So I'll get there too, no problems. Okay, so I hope this was useful. If it was, consider giving this video a like. If you have any questions, as per usual, just leave them down below in the comment section, and we'll talk soon.